good morning, good afternoon, good evening, depending on where you are watching me from. My name is Osobase Ime. I'm a teacher in Benson Idausa Cathedral Academy. I am the coordinator of tutorial with Mr. Abraham. I want to thank my subscribers, those who shared my videos to the extent of getting to the highest level. Students from 11 level students from Edo State University, Iyawo, requested a video on some topics in chemistry. So I'm starting with this: valence, electron, and valency. Before I go to the topic she asked me to teach her, I would like the viewers to understand, including ourselves, to understand what valence, electron, and valency is all about. Now, valence, electron, and valency, they are different in some ways, though they are all valence, valency, valence, valency. They sound the same, but the definition is different. Now, what do we mean by valency, electron? When we talk about valence, electron, we're talking about the number of electrons in the outermost shell of an atom. I repeat, when we talk about valence electron, valence electron, the number of electron in the outermost shell of an atom. Please, I want you to listen carefully. Valence electron, the number of electron in the outermost shell of an atom. Now, before I explain further, we have what we call the shells. The shells. What are the shells? We have the K shell, the L shell, the M shell, the N shell, the O shell, just like that. It goes like that. Now, the K shell is the first shell and is termed 1. The L shell is the second shell and is termed 2. The M shell is the third shell and is termed 3. The N shell is the fourth shell and is termed 4, just like that. Now, these shells have the maximum amount of electron each of them can carry. Now, for you to know the number of electrons that each shell can carry, we have a formula of 2n to power 2. This is the formula of looking for the shell of the electron that each shell can carry. Now, since we have K as number 1, we'll say K equals to 2 times 1 power 2, because K is the first shell and is number 1. So we now have equals to 2 times 1 square is 1 equals to 2. That means the number of shell that K can carry is 2. Please take note. When I say the number of shell that K can carry, it does not mean that it's only 2 that K can carry. The maximum number of shells that K can accommodate is 2, while the minimum number of shells it can also accommodate is 1. That means it can accommodate 1 and 2 shells, electrons, so they can accommodate 1 and 2 electrons inside the shells. Please listen very carefully. I said the number of electrons that can accommodate K shell is 1 and 2. The minimum shell is 1, while the maximum shells is 2. Now we are through with K shell. That means K can carry 2 shells. Now let's go to L. We have L. L equals to 2 times N squared, our formula. Then we have L equals to 2 times 2 is the second shell, so we have 2 square. We have L equals to 2 times, what is 2 square? 4. Now 2 times 4 will give me what? 8. That means the L share can carry 8. Please listen very carefully. The L share can carry 8 electrons. Now the L share is, we also have 1, 2, 3, 4, 5, 6, 7, 8. The maximum number of electrons that K share can carry is 8. Please take note. It cannot accommodate 9. Then we'll come to the M share. Now for the M share, we have N equals to 2n squared. N equals to 2 times, we have 3 here, to become 3 squared. N equals to 2 times 9. Now 2 times 9 will give me what? 18. That means the N share can carry 18, a maximum of 18 electrons. Then we come to the N share. The same formula, N equals to 2n squared. N equals to 2 times 4 squared. N equals to 2 times 16. N equals to 32. So you can see the maximum number of electrons that the N share can carry in its share is 32. So all students need to understand the number of shares that each number of electrons that each shares can carry. Please, that must be noted. Now let's go to the topic of the day. We said valence electron. Valence electron is the number of electrons in the outermost share of what? Of an element, of an atom. Of what? Of an atom. Now let me explain further. If, for example, you are asked to look for the valence electron, they said, how many valence electron does carbon have? How many valence electron does carbon have? Now let's solve this, please. Carbon is a non-metal. Carbon is a non-metal. It belongs to group 6 in the periodic table. Now this is carbon, for example, and carbon is 2, 4. Since I have 6 here, I have carbon, which is 6, equals to 2 and 4. This 2 means it can contain 2, it has 2 electrons in the K share. This is the K share, and this is the L share. Remember, I told us that the L share has a maximum number of 8 electrons, but it can also accommodate 4, but not more than 8. So this 2 belongs to K share, and this 4 belongs to L share. Now, how do we know the valence electron? Like I said before, the number of electrons in the outermost share of an atom. So what we call electronic configuration. So let's draw, please. Let's draw. So, for example, I have a cycle. This is the first share, which is your K share, and it will accommodate 2 electrons. 1, 2. Now I have the L share. Remember, the L share can accommodate 8 electrons, but in this case we have 4 here. So I have 1, 2, 3, 4. So remember, I said before the beginning of this video, I said valence electron is the number of electrons in the outermost share of an atom. Now you can see this is the outermost share, which is what? Your L share. Now how many electrons are in the outermost share? 4. Therefore, carbon has 4 valence electrons, because 4 electrons are in the outermost share. I want to believe this is you understanding me? Is that clear? Carbon has 4 electrons in its outermost share. Now let me use another example again. Let me use magnesium, for example. Let me use magnesium. Magnesium has a symbol of Mg, and it is 12 in the periodic table. And magnesium is 282. 282. Now, this first 2 is the K share. This 8 is the L share. And this 2 is the M share. So you can see, this K share is complete for 2, while this L share is complete for 8. Then, if you remember our M share, from our M share are supposed to be having 18, but yet is 2. Yes, we can accommodate from 1 towards 18. Now, let's draw the configuration of magnesium. We have the first share, which is your K share, 2 electron. Then we have the L share, which is a what? 8 electron. 4, 5. We have 1, 2, 3, 4, 5, 6, 7, 8. This is your L share. Now, to the last share now, which is your M share, we have 2 electron. Now, 2 electron in the outermost share is called your valence electron. 2 electron in the outermost share is called your what? Valence electron. So you can see, valence electron is the number of electron in the outermost shell of an atom. So if you draw your configuration, the number of outermost, the electron in the outermost shell tells you the what? The valence electron. So let me do one last example for you to understand. I'm still in valence electron. Let me do chlorine. So we have chlorine. Chlorine is number 17 in the periodic table, and we have 287, because 2 plus 8 is 10. 10 plus 7 give me what? 17. So this is your K share, this is your L share, and this is your M share. Now I'm going to draw the K share. Who is the first one? It accommodates 2 electrons. Then the other one is the L share. It accommodates what? 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. And the last one accommodates what? 7 electrons. So we have 1, 2, 3, 4, 5, 6, 7. Are you getting me now? Now, how many electrons are in the outermost shell of chlorine? So we have 1, 2, 3, 4, 5, 6, 7. So chlorine have 7 valence electrons. I repeat, chlorine have 7 valence electrons. That's the meaning of what? Valence electron. So for my viewers watching at home, let me give you an assignment for you to do. So do it and put on the comment section below. How many valence electrons does sodium have? How many valence electrons does sodium have? Please do it and put your answer in the comment section below. Now let's go to valency. Let's go to valency. For valency, it's almost the same thing but different definition. Valency. Valency. This is the number of electron lost or gained by an atom. This is valency. It is the number of electron lost or gained by an atom. But some textbooks will tell you it is the combining power of an element. Yes, it's also correct. We can say valency is the combining power of an element, or valency is the number of electron lost or gained by an atom. Now, if you remember, we have metals and non-metals. Metals loses electrons, while non-metals gain electron. That is what this definition is telling us now, that the number of electrons lost or gained by an atom. That means this very definition is related to what? Both mentals and non-mentals. Mentals and non-mentals. Please take note. All right, let me give you an example. Let me take an example of sodium. Sodium is 281, which is 11, because it's the periodic table. 281, and sodium is a metal. So let's draw the configuration of sodium. So the first share is 2, 1, 2. The second share is 8, 1, 2, 3, 4, 5, 6, 7, 8. While the last share is 1. Now, because sodium is a metal, it will lose that only one electron in its outermost shell. Please take note. This one electron in the outermost shell is also called valence electron. When it comes to the definition of valence electron, because valence electron is the number of shells in the outermost, the number of electron in the outermost shell of an atom. Please take note. I repeat, the number of electron in the outermost shell of an atom. So this particular electron is valence electron for sodium. So this one is your valence electron. Valence electron. Please, this must be noted. Is that clear? And also, that one electron in the outermost shell is also your valency. Now, how is it valency? Like I said before, valency, this is the number of electrons lost or gained. Now, by definition of metals, metal loses electron. So it is that one electron that sodium will lose. What we call valency. So like I said before, I said valence electron and valency, they are almost the same, but they are different in definition. So valence electron is the number of electron in the outermost shell of that atom, while valency is the number of electron lost or gained by an atom. So sodium is a metal. Since you've drawn the configuration of sodium and you have one electron in the outermost shell, it will lose that one electron. Now let me pick another example, another metal. For example, like aluminium. Aluminium is Al and is 13. So we have 2, 8, 3. So I will draw the first shell, the second shell, which is 8, 4, 6, 8, and the third shell is 3, 1, 2, 3. Now, these 3 shells you are seeing can be called valence electron. Why is it valence electron? Because it is 3 electrons in the outermost shell. So aluminium has 3 valence electron. Please, this must be noted. Like I said before, valence electron, the number of electron in the outermost shell of an atom. So it has 3 valence electron in the outermost shell. Now let's come to valency. We said valency is the number of electron lost or gained, and aluminium is a metal. Aluminium will lose its outermost electron, which is the 3. So we have 1, 2, 3. So aluminium will lose the 3 electron. So that losing is called valency. And now it's called valency. So we have 3 valence electron and 3 valence and 3 valency. And now 3 valence electron and 3 valency. Please take note. Now I've done 2 metals. Let me do 2 non-metals, please. Now let me take fluorine as a non-metal. Fluorine, F. Fluorine is 9, and the configuration is 2, 7, because 2 plus 7 is 9. So let's draw 1, 2. 1, 2, 3, 4, 5, 6, 7. Now please listen very carefully. Now for metals, they gain electron. This must be noted. They gain electron. Now, that's what we call the octet and the duplet rule. Please take note. The duplet and the octet rule. Now, the duplet rule is a rule where atoms tend to complete their share by 2. Exactly. While the octet rule is when an atom completes its share by 8. For example, now I'm having 2 7 here. So I need 1 electron to add to 7 to become 8. I will call the octet rule. Like sodium, like hydrogen is 1. It's just 1. Like so, hydrogen needs 1 electron to add to this 1 to become 2. How will we call the duplet rule? So hydrogen and helium, they obey the duplet rule because hydrogen is 1, helium is 2. You can see hydrogen needs 1 electron to add to this 1 to become 2. How we call duplet rule? While helium is already 2 duplets. So other elements again, they need extra electron to add to them to become octet. Like fluorine we just mentioned now, it is 2 7. So fluorine needs 1 electron to add to this 7 to become 8 to what? Obey the octet rule. Now we have 7 in the outermost shell. How many valence electron is fluorine? Now since we have 7 is outermost shell, fluorine have 7 valence electron. That is the answer. I repeat, since we have 7 electron in the outermost shell, fluorine has 7 valence electron. Now let's go to valency. Now, like I said before, valency is the number of electrons gained or lost by an element, and non-metals, they gain elements. Now, how many electrons will fluorine gain to become octet rule? Like we said, it is 1. So fluorine needs only 1 electron to add to this 7 to become 8 to obey the octet electron. So if fluorine can attract 1 electron to add to this to become 8, that 1 is called the valency. So fluorine has 1 valency. So you can see now, valence electron is different from valency. So let me give you assignment. Please drop the assignment in the comment section below. Now, how many valency does chlorine have? Please drop your comments, drop your answer in the comment section below, and I will get back to you. Thank you and have a nice day. Bye.